Good afternoon, ladies and gentlemen. I'm Cash Bailey.
My name is Carlos Mendez.
My name is Ayman Samak.
And together we are
Rising Star.
We're here to present an opportunity to invest in a 10 to 20 megawatt natural gas fired power plant designed to power a data center located near Laredo, Texas, the gateway city, which is the largest inland port in the United States.
Now, transitioning into the location and resources, why did we select Laredo? First, we had to establish a set of criteria where our location must satisfy a demand for data center infrastructure, that there is existing infrastructure for the transportation of natural gas and other resources, and that the county has sufficient natural gas production in order to feed the natural gas power plant. So by evaluating Laredo is the gateway city to Mexico and is one of the most critical international trade hubs in North America. Yet despite that strategic importance, it remains significantly underserved in data center infrastructure compared to much larger markets such as Dallas, Houston, and Austin. Now, we're already seeing major data center interest in Webb County, one of which is the proposed Data City, Texas, which is a project that is set to be established near Laredo. At the same time, this region sits directly on top of a substantial natural gas reserve, the second largest natural gas reserve in the state of Texas, that being within Webb County. Now, by investigating the county, we found an area of interest where there is existing natural gas infrastructure to move that natural gas in order to feed the power plant. In addition to that, it is strategically placed with great intermodal access, such as highways and railroad connections. And on top of that, it will be established near a new developing $7 billion community that is known as Telis. By investigating and forecasting the production within the area of interest itself, we found P10, we forecasted a P10, P50, and a P90 scenario, where P50, that being the most likely scenario, forecast that only a quarter of the total production within the area will be required in order to generate sufficient volumes of electricity.
Moving to the plant configuration, our solution is simple. We put the power plant where the gas comes from. We choose a combined cycle gas turbine with a closed loop air-cooled condenser. We need a closed loop system to preserve water because the area is drought prone. We chose the CCGT because compared to other options, it's more fuel efficient and it's less expensive in CapEx and OpEx. For this project, it is the best techno-economic option. More importantly, it will reliably power the data center.
Our business model is straightforward. We sell electricity directly to a data center at 3.8 cents per kilowatt with an annual escalation rate of 9.8%, which yield a net profit margin of 48%. Now it's time to answer the question that must be hovering over your head. How much I'm gonna get when I invest with Rising Star, and how safe is it? To answer this question, we focus on three numbers. First, the MPV, which is simply the profit you make by investing with us. Second, IRR, which is the project annual rate of return. And third, the payback period, which tells you how long it takes to get your money back. We looked at 3 different scenarios and 6 different time horizons, but we decided to go with the average case for 15 years. With the 15 years of operation, our project generates an MPV of $15 million and an IRR of 14% and payback period of 10 years. So you technically get your money back at year 10 and then keep making money until year 15. To validate our results and also quantify our risk, we ran a sensitivity analysis with 15 random outcomes, which almost all the key variables, the CapEx, the OpEx, the electricity price, and the capacity factor, and the discount rate move up and down by at least 20%. With the median results, what we call B50, the MPV stays close to the $15 million, which matches our average case scenario and also in line with the project that use CCGT to produce the same amount of electricity. It's also worth noting at the B90, our MPV is 3.5 million, which means that in the worst case scenario, we were not losing any money, with the potential to earn $30 million in the best case scenario. Now, where it gets more interesting. Since the industry average lifetime of the planet is 25 years, what would you do after year 50? So we're proposing 2 different options. The first one is to sell the business at year 15. which will generate an additional $19 million and bring the total value to about $34 million. Option 2 is to hold the asset until year 25, which will increase the total value to $47 million. So you're technically not locked into just one outcome. We're asking for $22 million, which fully covers the project capital cost. The investment is split over 2 years, 60% at the first year and 40% in the second year. In return, the project delivers a $15 million of MPV, $34 million when you include the terminal value, which if you decided to sell the business after 15 years, a cumulative discounted ROI, or as known as profitability index of 1.6, where a PI above the 1.4 is considered a superior investment. So again, you get your money back in the year 10 and you earn at least 14% annual rate of return, which is relatively higher than any other investment option once we account for the time value of the money at over the 15 years horizon. So we promise you a rate of return between 14% and 19%. With all these promising numbers, would you invest your money with us?